Hello friends, welcome to our channel. In this lecture, I would like to explain another topic based on the one-way slab. Already explained continuous beams and 2D frame, but in this lecture, I will explain analysis and design of one-way slab by using STAAD Pro Connect Edition. So here, select new and by default choose structure's name whatever you want. So I will choose one-way slab here, one-way slab, and keep your file in your default location and select analytical and units metric and then create a new model. Okay, so after selecting all these you will get a default user interface. So this is the default user interface. So here select the grids in geometry and then beam grid option. See here you will get grid like this in XY plane. So already I told you how to modify this grid. Here select edit option. So already I told you I will draw analysis and design in our topic today. So here it will be in the XY plane. So I will change my plane in XZ direction and all these properties will be okay. Then at the 0th node I will select in the X range of some 3 meters and again in the Y range of 8 meters. Why? Because for drawing one way slab your Ly by Lx ratio 8 by 3, that is in the longer span direction it will be 8 and shorter span direction it will be 3. So if your ratio will be greater than 2 it will comes under the one way slab, otherwise it will comes under two way slab. If your ratio will be less than 2 it will comes under two way slab. Therefore I will take the values related to the one way slab only here. Then again I will take in the x direction 3 and again in the y direction 8 meters. Then from coming out of this command I will click escape. Okay, then again in the geometry grids close that grid pattern. Select by selecting beam grid you can close that grid pattern. See here this is the panel which is related to the slabs and here I will use one new command, that is translational repeat command. So here in the geometry itself aside of structural widget you see this symbol. If you keep cursor you will get translational repeat. So here today I will use this command for making these columns and beams. So click the translational repeat command. So after clicking that one you will get a dialog box like this. See here global x direction, y direction, z direction, and again number of steps will be 1 meter, default step spacing will be 5 meters and link steps. All these things are there in the translational repeat dialog box. First in the y direction I will select nodes and I will show how it will works. So in the select option I will select node cursor and I will select only nodes and again I will select in the geometry translational repeat command. Here I will select y direction and then default step spacing will be some 5 meters like that only. Okay, and then I will click OK. See here select the node cursor and then click OK. See here what happens. So the nodes will be appear on the upper side of the panel. Okay, here if you want downside what you have to do in the translational repeat command I will show once again. Translational repeat command y direction. If you want the same nodes in the bottom direction along with both nodes and beams, so select entire beams and nodes. Okay, select entire by using geometric cursor, select both beams and nodes and then click default spacing, step spacing, give -5, then you will get both the structure in the bottom direction. Okay, see here how it works. If I will keep minus and I will select only node, means only nodes will be appear on the upper side. If I will select entire structure and I will give negative in default step spacing, automatically the entire structure will be appear on the bottom direction, bottom side. Okay, and again here one more option will be there. So what is that option? Links. I will show that one in the view, geometry, translational repeat. Here link steps. So use this command also. How it works? You see, I will select entire structure and I will give in the y direction. Default step spacing will be around some -5. And if I am choosing link steps option and then click OK, what happens? So there is a connection between upper panel and lower panel. Means these columns is the link steps options which is highlighting here. So like that the link steps commands will be works. So I am showing this translational repeat command how it will works. In the same sense, I am giving only x direction. If you want the same things in the y direction, see here, select in the x direction, choose entire panel by selecting the geometric cursor and again select entire panel. See what are the things I selected here. Entire things will be selected and again link steps. The steps range will be some 3 meters. Why? Because the panel in the x direction will be 3 meters only. Click OK. See here, including this panel along with the nodes also selected. If you select only structure, only structures will be copied. I will show that one also. See here, in the x direction and y direction how it works. Again I will select geometric cursor in the y direction. I will keep columns of some default 4 meters. So I want bottom side. So I will keep -4 and along with the link steps I will select only nodes here for drawing my structure and then I will click OK. So see here the panel will be like this. Again I will use translational repeat command in the x direction. So I will give 3 meters spacing in the x direction and I will link the steps and again selecting the structure through geometric cursor entire structure and then click OK. So what happens? Another bay will be formed in the right side x direction. If you give negative value means it will comes left side. In the z direction means it will come in the z direction. If you want multi-story frames means like that you can create multi-story frames. For example, you can select the entire structure and again use geometry cursor, translational repeat in the y direction. Entire structure default step spacing will be 4. Number of steps like I want some 5 steps. Okay, link steps command, using link steps command, click OK. So see, this is the multi-story frames. So this is how this translational repeat command works. So today my concept is how to utilize translational repeat command also. Then I will draw simultaneously one-way slab. So next you know how to use this translational command because it will be useful for drawing projects. Okay, like multi-story frames and buildings. Then I will show how to design one-way slab. See here, this is the single bay, single story portal frame which is panel in 3D mode. Okay, so our next step is as usually create the supports. So then click the supports button and then here select create and again here select fixed supports. By default it will be fixed only. Click add and here how you will assign, you can, if you select only nodes means top nodes also selected, therefore in the view select front view. Okay, select front view and then select bottom nodes and see in the isometric view. So if you observe only bottom nodes will be selected and then click supports, again select these nodes, see in the isometric view, and then assign these supports to the selected nodes. Like this, you have to assign that particular support to the particular nodes. Then next step is to assign the properties of the beams, columns and slab. Then click sub properties, and again here you have to define the property. So choose circular for the columns. I will give around some 0.5 meters and click add, and for rectangular for the beams what are there, that is 0.45 by 0.3, click add and close. And again for this panel slab purpose, you can select thickness of the slab, then click thickness, and then here there will be one element showing here, plate elemental thickness. You can choose the slab thickness will be some 0.15 centimeters or 20 centimeters. So I will choose around 15 centimeters only. The thickness of the slab will be 0.15. So this is the trial version. I will choose approximately that much. Click add and then close. So we know how to add these circular columns. Again keep your structure in the front view mode and select circular column, and then select only these beams and check in the isometric view whether 4 beams are selected or not, 4 columns are selected or not, and then click assign to the selected beams and then click OK. See here R1 means it will be assigned. Then again I will select rectangular one. So here it will be difficult to select these beams x in y direction in the front view. Therefore here I will choose select in this again parallel to xz direction. So if you select this one, only beams will be selected which were in the xz direction. Okay, then I will assign it to the property to the particular beams. Then you have to assign this plate also. So here beams and columns will be there, but there will be no plate will be created here. Therefore for assigning that plates, we have to create some mesh here. So for that you can see here in the geometric, again there will be one option, an icon which is add plate here. Here if you drop down this one, you will get triangular plate, but here this is quadratic plate. Therefore in the top itself, if you keep like this, you will get add quad plate. So click there itself. Then you can add quadratic plate here, 1 2 3 4, because it is a 4 noded quadratic plate, so it will close to this end. For example, there will be one more another option, again in the geometry generate mesh will be there. If you click this drop down, so here create mesh will be there. If you click this one, it will stops up to 5th node, starting from 1 2 3 4, again it will be at the 5th node. So don't, if you want you can choose this option also, if you want you can choose this option. So I will use this option while drawing two-way slabs like that. Okay, so now I continue with this option only, add plate. I will select plates here, just make it confirm. In the select, check plate cursor and then click on this upper slab. If you see here plates will be selected, why? Because plate will be added now itself, and then for that particular plate you can add this plate thickness. Again I am adding here, click assign it to the selected plates. So we make it conform. We added all these three things: circular columns, rectangular beams and plate. So for that, in the view, again check with 3D rendering view option. See here, after clicking that one, you will see the entire structure in 3D mode. If you observe here, the columns will be in the circular mode, and this beams also in the rectangular mode, and the slab which was in different color here. So all this will be assigned. So this is the 3D view, and then after assigning these properties, then select then apply the loads to the particular frame. So for that you can choose. So first I will come out of this command. So see the cursor which was in plates cursor there, I will come in by escaping the pressing the escaping button. I will come out of this command and again select loading here. So same like previous how we applied in the load case details, select add and then here dead load. So if you want you can give default name dead load like that, and again add here and close, and again load case details, add, again here you can select live load, here you can choose again live load LL, and again add, close. Here again in the dead load, add. So just to give self weight of the structure to the entire structure, so just by default you can choose -1 like that only. In the first, while solving the first example continuous beams, I explained each and everything in detail, so always it is useful to come from the first video. Okay, then again in the live load you can click add, and here we know, just first I will keep the member load for uniform member load for the beams. For that I will take some -30 kilonewton per meters, and again in the y direction I am not choosing any value here, distance here. Why? Because I want to apply entire uniform load for the total beam, and then click add here, close. And again in the live load itself I will select add, and again here for the plates I will give plate loads or floor loads. So here in the floor loads, first I will choose this floor load. Okay, here after highlighting this one you will get the dialog box like this. Here I will give plate load pressure of some 10 kilonewtons, minus indicates downward direction, and again we are applying the loads in y direction only. And here define y range. For example, if there will be multi-story frames, your range will be selected from 0 to top floor, but there is only one floor, so therefore we are not selecting y range here. And in the x range we know the L by Ly longer span ratio and shorter span ratio, it's come from 0 to longer span direction will be up to 3, sorry, shorter span direction will be up to 3, and longer span direction will be up to 8, so which is 8 by 3. We know the ranges, therefore we are fixing here. Otherwise you can choose how much it will be, so I will show that also. So in the while explaining two-way slabs, I will select some multi-story frame, then I will make use of these commands, all these command y range commands also. Then click here OK, and here you can remember one more thing. So we are designing one-way slab. So we know for one-way slab, longer span we can keep only distribution bar. In the shorter span direction we are assigning main reinforcement. Each and every one know, for the two-way slab both in the longer span and shorter span direction we are keeping the reinforcement, but in one-way slab in the longer span direction we are only giving distribution reinforcement. Therefore while designing the one-way slab, you please highlight this one-way distribution, click this box, and by default you can choose default longer span direction only. Okay, and again click add here and close. First assign self weight to the entire structure. For that I will make use of assign to view command, then only it will assign to the entire structure. And again uniform load, so uniform load especially assigning to the only beams, therefore I will select uniform load, select in xz direction, in the select command parallel to xz, and again click OK. So beams will be selected, and here I am assigning that particular value to the beams. And in the loading panel, check view loading diagram. After seeing this one, if you observe here, your UDL will be selected, but here the load will be assigned in upward direction, so therefore keep here negative. I am always telling that you can keep negative for the downward direction, and change here, close. See here the uniform distributed load will be assigned to the beams, and if you click here for the one-way distribution, and again see here the load will be distributed only on the one-way side. For example, if I am not selecting this one, what happens you can observe once. See here the load will be distributed equally on both sides. So while designing one-way slab you can choose one-way distribution only, and then click yes here. So automatically the floor load will be assigned. Okay, you don't need to assign manually again. Then so this is the way how to assign the loads to the particular multi-story particular frames while using slabs. Then go for the analysis. define commands and run this analysis. Here save the structure, wait for a while. See here, it will be analyzing. So it will be loading. See here, there will be 0 warnings and 0 errors. So if there will be any errors, please rectify here itself before going to the design and then go for the design. So here there will be 0 warnings and 0 errors. I will go to the design part. So for design, select here design tab and then here concrete. By default it will be steel design. If you select this concrete one, automatically you will get concrete design here, and again by default it will be in the current ACI code. So select IS 456 here, and again here after choosing IS 456 in concrete, select parameters here, select parameters. Here we know what are the basic things required. So generally we are designing M20 or M25 grade concrete. So minimum grade of the concrete we are using M20. So I will take above value which is M25 like that. So for that I need a compressive strength of the concrete. I will select that one, and main reinforcement we are keeping main reinforcement which was in HYHD bars like 415 or 500. I will select one that also, and for strength reinforcement and beams and the columns I will select shear reinforcement FI secondary also, and then I will select these three parameters. Don't select minimum and maximum bars. STAAD automatically taken based on this area of the steel. Okay, and then define these parameters. For example, I will take FC, characteristic compressive strength of the concrete. I will take M25 grade concrete which is 25. So generally it will be in terms of Newton per meter square, but here it will be given kilonewton. Therefore I will take into 1000. Click add, and again FI main I will choose 415 bars and again into 1000 because of kilonewton, and again click add. And again for secondary reinforcement, we people know if I will given 250 means you will get only plain bars which was in 6 dia, but we don't know based on the area of the steel only even stirrups also assigned. So I will give by default 415 or 500. Okay, again 415,000. Click add and then close. And here after assigning these three, in the commands select what are the topics you want. So here there will be beams in my panel, so I will select design beam, add, and again columns in my panel, select design columns, add, and again slabs in my panel I will select design slab, add, and then take off. Take off, for example, if you are designing only beam part, take beam and take off. If you are designing only column, take column and take off. If you are designing combination like this means take the combinations and then take off. Take off must be taken for the design purpose. Okay, then assign all these commands. First one is FC. So characteristic compressive strength will be assigned to the entire structure, therefore I will select assign to view option. If you observe, so entire structures will be assigned MC, and FI main reinforcement also assigned to the entire structure, therefore I will select assign to view option, and FI secondary reinforcement also assigned to the entire structure, I will select assign to view. Then see here design beam will be taken only for the beams, therefore I will select only design beam, and then again in the select option parallel to XZ direction. So here I am applying this command only to the beams which was in XZ direction, and then assign to the selected beams, assign here. And again I will select design column only to the columns which was parallel in XY direction. If you see here, only columns will be selected, and that too only two columns will be selected. So for that what I will take means I will view in front view, and I will select entire beams, and again I will check with isometric view, and again I will select that column to the 4 beams, means columns here. And again design element, first select these plates by using plates cursor, and then you can assign that element to that particular slabs. So your design will be completed. We assign all the things. Check once. Again go make use of analysis commands and define the commands. And again I will choose print all option, add, close, and again I will run analysis here. And then click save here. Automatically your analysis and design will be completed. Again 0 errors and 0 warnings. So view output file also. Later we will discuss that things also. Before viewing output file, you see the concrete design. For seeing that concrete design, check in post processing mode. See here, there will be post processing in this workflow table. So select this post processing mode. Okay, if you select this one, click OK. Here we will see all the ranges. See here, if you want to, you can view in tabular format. Otherwise you just see here the diagram how it will be. So I want movement in y direction. I will select movement value here. See here the movement will be like this. If you want values, annotate values, select beam results, bending, shear results. Only maximum values I selected. If you want end values you can select, but it will be clumsy if you want to check all these values means, and maximum resultant values also. Click annotate here. Okay, see here the values will be visible like this. And again if you want forces in y direction, and close this movement in y direction. So you can see here only shear in y directions for the beams will be highlighted here. For columns you will get axial also, then you can select axial forces also, no problem. Then whatever the values you want, you can see here axial at the ends. If they will get means you can see here. So there is no axial means you won't get any values. So there will be no axial values. So whatever the values you want, you can choose here. And then choose the reactions, beam results, whatever you want here. Solid results. So whatever available, you will get all these values here. Then again in the analytical mode, check the column design, how it will be. So if you select that column and then click concrete design, see here the columns will be the circular column, and the number of bars will be available here. So we selected 415 and FC will be 25 and area of the steel required will be 3104. Like that each and every value, bar size will be taken as 20 and 10 in numbers. Like that we will get each and every detailed value here. And if you want, you can choose any particular beam like this. And for the slabs you can check the post processing mode. So in the post processing mode means output file, you can see the output file in the concrete design. If you keep on seeing this output file, you can see all the things will be there, details in our output file. See here top reinforcement, bottom reinforcement, and what are the bars they will taken here. So the length will be 400. So column number 7, if you observe any particular column, the length of the column which given as 4 meters, cross section is circular dia will be 500, covered by default it will be chosen 40, minimum cover for the columns they maintain minimum 40. Like that STAAD will take in minimum, even though we are not giving any values, it will take by default. So each and every value will be there here. And again the bars will be taken, 8 bars for stirrup and 10 bars beams, columns, and for slabs the total area of the steel will be here in this particular frame will be 6565. So like that you can manually calculate also. By taking these values you can see manually how can you calculate manual also. Okay, so all these things will be coming into the design. So I hope you understand this lecture. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.